So yeah, great to have this webinar. I think, is it the first one this year? I'm starting to lose track, but I think it is. So quite an interesting one around the topic of AI in pricing and revenue management. We'll deep dive, of course, into how we're using AI and also explain it a little bit generally about the topic, what the benefits are, what some of the pitfalls are, and how it's used today. And hopefully have some good insights in terms of what the potential is for this technology. So do you want to go to the next slide? I think we have a quick intro. So my name is Paul. I'm head of sales at Buynomics. Previously worked in consulting and leading the customer side of things and the contents and insights of Buynomics. Ingo, you're the founder of Buynomics with over 12 years experience in pricing, and you also developed the method. So I think quite good to have you speaking again about this topic today. If you want to go to the next slide here, then I can shed a bit of light in terms of the context of Buynomics. So just a little bit of an intro for those who don't know us. We're a German SaaS company, so software as a service, founded by two experts in pricing and revenue management, formerly Simon Kutscher. Developed a very unique software that basically reproduces how shoppers or consumers think and make decisions. And we'll dive very deeply, I think, into that middle part here. But overall, we're working in a lot of different countries around the globe. I think we can even color some more on the map on the right-hand side. But in verticals like CPG or FMCG, internet, telecoms, etc. So I think something here for everyone, regardless of the background. So yeah, with no further ado, Ingo, I think if you want to start.
Yeah, thanks, Paul, and also a warm welcome from my side for our first webinar in this year. We'll have more coming up in the next weeks. I think we'll have an overview at the end of the webinar. All right, so we're kicking off the year with topic machine learning AI in pricing, revenue management, so our broader topic. I think we'll have something to add to the discussion, particular the way we're treating the topic. I think that's interesting. But we won't go into too much of the very technical mathematical details. Happy to discuss these if you're interested in follow-ups. If there's the need for that, we're happy to we can actually also do a webinar specifically on that afterwards. But here is, and also light on the audience, the focus on giving a broad introduction, explaining the topic, what are the challenges in our field in pricing, what are the approaches, and then also how we are approaching the topic. All right, so to get started, let's start, and maybe some of you have already seen this in some way, with clarifying a bit the terminology. So there are a couple of words that are describing the topic. I think I often see them being used interchangeably, but I think it makes sense to use this understanding here. So artificial intelligence is essentially the broadest concept, getting the computer to do things that typically only humans can do, recognizing pictures, recognizing videos, contents in videos, and in our field doing maybe better pricing decisions or helping pricing managers to improve pricing decisions. So that's the very broad field, and then that somewhat narrow field of machine learning, and I think that's going to be the focus here, and is often the focus when people talk about artificial intelligence or machine learning within the topic of pricing, is getting or having a set of statistical methods that help computers improve and to better understand the specific data, sales data, pricing data, for example, in our context, to improve prediction specifically on how customers react to changes in prices or changes in in a product offer. And then within machine learning, there's the, say, in our context here, the narrowest understanding, deep learnings, and that refers to a very specific type of models that are used using neural networks that can be used to help machines better understand and learn from data. I think pragmatically, often what I see is people say they're doing AI or machine learning when they're using the proper or the relevant tool sets and packages like Python, MATLAB, or any other software. So this is what we're talking about, and I think the focus here is going to be on the middle, the machine learning part. All right, to get started, I think it makes sense to put the proper context of how this machine learning approach differs from traditional, maybe regression-based statistical methods that are often being used, and it's sometimes, in some cases, it's not clear where classical statistic ends and machine learning begins. But I think from the idea, the core difference and is that classical statistical methods, like when you're looking at a regression analysis, for example, or you're doing anything that's based on a sample of data, not the full data, you typically start with a model, with an understanding, derive hypotheses, and then validate or falsify your model. So you have an hypothesis, say, if I increase price by 10%, I will lose 10% in sales. And then and that model typically is based on some understanding of the situation, historical data, or an understanding of how customers work. And then you test that hypothesis using some small sample. And the idea is, and where that comes from, essentially that approach comes from the time before computers that can do a lot of computation. And so the idea is you need to have methods that also work with limited computational capabilities, paper and pencil, for example, and work with limited data, sample instead of looking at the whole data set. Now, the idea of, to do that, you need to have typically very restrictive assumptions. So you work with normal distributions where it's okay to only look at a sample of the data and you don't have to look at the full data. So that's, I would say, the traditional statistical context, and in itself, it's consistent, and you get problems when some of these assumptions are violated. So, for example, in finance, when you assume that stock price changes follow a normal distribution, then you will make large errors, and these can be very costly in that context. But if all the assumptions are valid, then that's also a valid approach to look at reality. So in machine learning, on the other hand, the approach is essentially in the opposite direction. You don't start with a model, but you start with data. So you have a way of understanding data. You don't really have to have very strict assumptions like a normal distribution or something else, and just build a model based on the data that you see. And of course, that works very well if you have a challenge like a picture recognition that's difficult to put in a standard statistical model. It works well when you have a lot of data, can look at a large number of different cases. So in our context, for example, in something like customer-specific pricing in B2B, where you have a large number of sales situations with different outcomes, where you can understand, or the model can understand, how customers react to a price increase, price decrease, and so on. So that's where machine learning makes a lot of sense. And when we then look into the specific methods that or let me, I think the order of the slides is not perfect. Let's do this first. So where do we see that in pricing? We typically see machine learning, for example, in large SKU pricing, spare parts pricing, for example, or when you have like someone like Amazon or another large retailer, lots of products where you have lots of price changes that you can observe. There you can draw conclusions using machine learnings with the capability to analyze large data sets. what I already mentioned, you have the same situation in something like customer specific pricing, where you also have, because every customer potentially has a different price, the option to look at very many cases, things like dynamic pricing in hotels or airlines. Also lots of this pricing situations where you can learn a lot about how demand reacts to price changes or offer changes in general. Also, of course, in revenue management, when, for example, in consumer goods, you are in a situation where you have a different offer at each different retailer in each week. So there's a lot of variation in the offer, and of course, also a lot to learn. And that's one context in which we have a lot of experience in how to best do that. Industries that relate to these cases are airlines, for example, retail, insurance. Insurance also, for most insurances, each customer gets a different price depending on the specific risk and situation. So each car, for example, has a different price. So these are the cases where it makes sense. And so far, so good. But what we see, or what is also one of the motivations for Buynomics, is that many of the techniques that are used, machine learning techniques, for example, clustering, where you cluster customers, where you think they have a similar purchasing pattern, or you cluster different products based on attributes where you think, okay, these should have about the same elasticity. These are techniques that are typically used. And then, of course, I think the second core workhorse is something like a regression model in different shapes and types. It could be a simple regression, multivariate, logarithmic, or whatever, to understand how price depends on, how volume depends on price, how volume depends on any other set of variables, for example, how the volume reacts to weather changes, how it reacts to changes in competitor prices. So all of these things can be studied using regression models, for example. And the purpose of that is, and I think, and in our experience, it certainly is the core challenge we have in pricing is understanding how demand reacts to certain changes. The second core challenge we have in pricing is, once we have understood the demand, is how we build the proper offer using that knowledge. And I think, and I'm happy to discuss this, but in our experience, that second question is much simpler. So if you have the demand function and you're looking at a single product, it's very easy to compute the proper price. So in the price optimum, margin times elasticity is always -1. So it's very easy to compute the optimal price if you're just looking at one product. So there's no competition, or you're working under the assumption that competition is constant, then it's very simple to compute the proper price, the best price, be it the profit optimal or the revenue optimal price in this case. If you're looking at a portfolio, you're looking at also competitor products where competitors might react to your changes, it's computationally a bit more challenging, but still fairly simple, because if you have a portfolio of, I don't know, a dozen products or so, you have a couple of competitor products, you're still only looking at maybe a couple millions of relevant options where you go for each product, maybe 1 to 3 price changes up or down. Not all combinations are relevant, because if you, for example, have a good, better, best portfolio, then they should be priced in order. So in the end, there are very few permutations or relevant offer options that you need to iterate through, and that's typically very doable with computer assistance. So the second part, the offer optimization, is typically very straightforward and simple. What's difficult is the first part, getting the demand right. And what we see, and also not only because we looked at it in the beginning, but also from what we're seeing for others, is that many of the approaches that we're seeing here in pricing aren't proper. And the way that machine learning is attached to pricing is often not done in the right way. And the reason is, and this is, I think, from our point of view, the most relevant reason is that when, for example, you cluster by price sensitivity, that's not a straightforward exercise, because you cannot really compare two products by their price sensitivity or price elasticity, in the same sense that you cannot compute the price elasticity of a product when you actually have some sort of a regression or linear or logarithmic relationship between a product's price and volume, because typically you don't have a single price elasticity for a product. So in this case, if you have a price demand function, a linear one, then the price elasticity is different in each point. And this is not just an abstract problem, but this is a real problem in the sense, if you take the example here on the right side, if you are in a point where you have elasticity of -2, you increase price by 10%, then your elasticity goes to -2.7. And the implications from that change in elasticity are massive. And in many contexts, a price change of 10% isn't massive. So it's something that happens. So you cannot characterize a product well with the price elasticity number. And many of the tools that are used for machine learning, I would call them, I would say, naive machine learning, because they use the classical statistic tools like price elasticity for pricing and attach a modern machine learning method to it. And that link isn't really proper. We believe, and you get all kinds of problems, because if you have a product that you have clustered based on a -2 elasticity, you increase the price, now it's -2.7, you have to recluster it, and you have to recluster it constantly. And that makes the basic analysis that attaches on a price elasticity very, very difficult. And in most cases, when people say they do machine learning within pricing, they work within a price elasticity framework. And I think that isn't proper. And we have, and I want to talk about one alternative to that. There are probably others, but here's the one that we propose and that we're using for our software. And to motivate that, oops. Let me start with this simple example, the Galton board. Probably most of you have seen it. So the idea is you have these pearls that drop through that machine, and there are little rods in their way. And essentially they go left and right, in this case here, with 50% probability. And if you do that, you end up with a binomial distribution here at the bottom. So you have a process here at the top, how these pearls run through the board, and they result in a specific distribution in the end. So it's the binomial distribution, or if you have a very large board, it will be a normal distribution. And what's interesting for us is, and what we also observe in pricing, is the distribution in the end that comes out. So we observe, if you have a good, better, best portfolio, that 5 people will buy the basic plan, 5 people will buy the advanced plan, 5 people the most expensive plan. That's what you observe. And the question is, what's the underlying process that creates this sales distribution? So that means for us, what's the underlying purchasing behavior of your customers that produces us? Because if we understand the purchasing behavior and the preferences of customers, then we can also show them other portfolios and understand if it would make sense to replace a product, to increase or decrease the price. All of that we can do once we understood the underlying process that produced the sales distribution that we're observing. And this is where we use what we call virtual customers or virtual shoppers. And essentially these are buyer personas, very small buyer personas. So one buyer persona for one real customers, and they have different behaviors, just like real customers. So they fall for price thresholds or not. Some share of them does. They have preferences. They can prefer one brand over another. They can they have a high preference for a large package or a small package, just like real customers, and they make decisions based on this. And essentially, if you very simplify it here, each one of these virtual customers has a set of preferences similar to what you would get, for example, from a conjoint study. And that's, I think that's the new part. You can get the same information, not just by asking people, but by looking at their past sales, at, for example, sellout data in shops. So what did people actually buy in different weeks with different offers shown to them? You get the understanding of how these virtual shoppers react, what their preferences are, how willingness to pay for a certain brand or a certain product attribute is distributed. And that we study using different machine learning methods. So we look at past data, for example. So we have this set of virtual shoppers. And in 1 week, we have this offer with these different prices, 2 products in a promotion with a lower price than normal, $10.44 instead of $13.99. We look at these different offers and they buy something else in each week. And from that, we, using different machine learning methods, we deduce how what the preferences of these virtual shoppers are, and with that, the preferences of the real shoppers. And we do that, for example, if we look at a large number of weeks, we get an understanding of their preferences, and then we can show them products at different prices in the future, and we can answer all kinds of questions. So in this example, for example, we trained our virtual model, and this is just one product out of many products. We trained it over a certain period of time, about 1.5 years, and then we forecasted using these virtual shoppers that were parameterized previously. And you see that given the actual promotions of this product and other products and other things going on in the market, the model produced a very high fit with reality. And once you can do that, you can, of course, also answer questions. What would happen if I change the price of that product? If I go up or down, how would that affect this product and the other products in my portfolio? So it might be good for a single product. If you, let's say, decrease the price of it, you increase sales massively, but it might draw some sales from your other products that are maybe more profitable, so it hurts you overall. So these are all the types of questions that that can be answered with a method like that. So once it's properly parameterized and you can use different data sources for that, you have an understanding of what will happen in the market. And as I said previously, the difficult part is getting the prediction right, the customer behavior right, and then the optimization. So asking the system, what happens if I increase the price, decrease? That's then fairly simple, as we never have realistically situations where we have to look at more than a couple million scenarios. And these are very easy to iterate through with a computer. I think, Paul, we're not running out of time, but we're getting close to that. So I think I would skip the tool demo. We can do that in another webinar, and I would go straight to the Q&A because I've seen that there are some questions.
Yeah, sounds good.
Before we do that, so I think the core is, and we of course, when we want to understand how people react to price changes, we at least implicitly have that assumption, and I think it's good to have strong minds on your side. So I'll close this part with a quote by Sherlock Holmes. While the individual man is an insoluble puzzle, in the aggregate, he becomes a mathematical certainty. And this is certainly what we're basing our model on, is that people in groups, not the individual person, but people in groups are fairly predictable. And that's also what the data that we have suggests massively. Paul?
Yeah, sounds good. I was just finishing some answers here to some of those questions. So in summary, we were asked a little bit in terms of what data we need, and I explained that in the CPG space, 36 months of data is sufficient. Of course, the more granular the data is, so if it's on a weekly versus monthly basis, and the longer it is, the more accurate we can refine the model. And with everything in machine learning and also statistics in general, I think the better the data used to train your model, the better the prediction will be. And we had some discussions around MAPE versus R squared, and we were asked what our MAPE is, so the mean absolute percentage error. I pointed out that that's highly dependent on outliers and therefore also on the number of data points that you have and kind of the level of aggregation that you look at. Do you want to answer a little bit on why we're usually measuring R squared versus MAPE, Ingo?
Yeah, so because it looks better? No, but it always, I think it depends on the context, right? So the MAPE tells you how close are you in each week to what actually happens. So that's relevant, for example, for logistics. If you want to plan how many products you ship next week, that's of course very important. If you're interested in assessing or steering the pricing over the year, then it's of course much more important that you get the price change right also over the year. It's less important that you get it right in each week. If you want to steer promotions and you have a certain type of promotions, 2 for 1, something like that, which you run in three or let's say 5 weeks, like a week on, week off, and so on, then it's more important that you get the effect correct over the 5 weeks rather than in each week. So it really depends a bit on the challenge, what measure makes most sense. And what we do is that we track a range of measures to evaluate a model, and that includes these different aspects. And also depending on what the question is, the model can be focused on the specific challenges.
Yeah. I also have a question from Steve, which I think rings very familiar with a lot of our clients that we currently have. He speaks about how can machine learning help in highly inflationary environments where FMCG brands and categories are entering unknown pricing areas. So can you speak a little bit about that dynamic, and especially, going into new territories that might have not historically have happened, and how machine learning would help with that?
Yeah. So I mean, even now or even a year ago, if you look at the whole world, you have all kinds of different contexts. So in Southern America, for example, you have countries with high inflation, and there you can already see, and we've certainly seen it, how large inflation countries behave, and insights from there can be also used in optimizing the models and getting the models to behave in a way that's to be expected also in a country. Here, Germany, for example, very low inflation the past years, and now it's increasing, to get an expectation of what will happen. Essentially, what inflation does for pricing is sort of a time compression effect. So you have an X% increase now within 1 year that you usually had over 5 years. That needs to be understood. And the basic answer is that overall, we already know that from countries, for example, that have high inflation, and that knowledge is then applied to the countries that are just moving into high inflation.
All right. So I think, and also to some extent, we can extrapolate from past behavior, right? Because unless the jumps are like super high inflation, like in Venezuela, then there's some similarity to the current price levels. So Thalel is also asking, how do you simulate the choices from competitors against the target products? Similarly, how do you model seasonality?
Can you say the first question, the competition?
So
I'm
assuming, how do you include competition in the forecast? So obviously shoppers or consumers or buyers decide between different products.
Yeah.
So how do you include them?
So the typical way is to have scenarios on how competitors will react. And of course, you have an understanding of what certain competitors have done in the past. So there are often some that will always follow the leader in a market. There are some that will always increase X% each year. And these behaviors can be are typically put into the different scenarios that you can look on, where you have, for example, a scenario where you say, okay, competitors will just keep doing what they did in the past. Scenario is competitors will follow us, and so on. And that's, I would say, the proper approach, because it's, of course, you don't know in the end what your competitors will do, but you can look at certain certain scenarios of what are likely reactions from them.
All right. And I have one more question. Again, you can ask them in the Q&A or in the chat directly, from Matthias, who's asking, what kind of models, do you use for the customer choice behavior? Classical discrete choice models, neural networks? Thank you.
Yeah, so that's a part that we wouldn't, we don't want to fully disclose right now. Yeah, so it's within the realm of mostly known models, and where we started, and these we have fine-tuned and are continuing to fine-tune to get better results.
All right. Need to leave some mystery, I think, to the secret sauce of Buynomics here as well. So I don't think I see any more questions at the moment. Again, feel free to ask them in the chat. I'll also put my email address in the chat right now. And Ingo, if you want to quickly go through the next webinar, I think we have a couple of interesting ones coming up. And I think Victoria has already said in the chat she's excited to see the tool in the next demo. And we actually have one exactly around that. So how we're going kind of technologically from Excel to SAS. That's the next one. We'll also be having a webinar with the European pricing platform, EPP, coming up in March. And we're also planning to participate in the Viper Innovation Summit with one of our data provider partners in the UK. So stay tuned. We'll put all of those on LinkedIn and invite you guys by email. And you'll receive the recording of this webinar by email as well. So take a look at your inbox and let us know as well by email if you found this helpful and interesting, and hope to see you at the next webinar.
Thanks a lot. Yeah, looking forward to that. And thanks, Paul.
Thanks, Ingo. See you soon.
See you soon. Bye.